So, it's been a long time since I did a stream. The audio is a bit loud. Yeah, it's been a long time since I did a stream, and I just wanted to do it now because I've been working now. I've a couple of projects, but yeah, I wanted to do it now. So, quick introduction. Today will be about a USB-C cable tester, and the background is I did. I have one? Yes. I did this little device, a micro B USB cable tester. If you've seen my videos, you probably already know about it because I made a video out of it. Simply plug a USB-A here, USB micro B, and the reason why I built this device was because I wanted to figure out if a micro B USB cable can transfer some data, because plenty of them now are just there to charge. And that was the whole purpose. Is the cable to charge? So let me show you this one, for example. This cable looks like a nice USB cable. It's only for charging. I've marked it already. But if I plug it here, if I plug it in, up, you see it only transfers power, and it's only for battery charging. It doesn't transfer data. So this one I should not use when I develop USB stacks, because then I don't know if I'm the culprit or the cable is the culprit. This one is shielded. It means that it can transfer data, and it's a shielded cable, so it's a good cable. It's one of the good ones. If I plug it in, you see power, data, shield. Means that I can use this cable for high-speed data and for data. So that was the whole purpose of building this device, and I also selling it on my store just because I produced too many of them. And because I wanted the experience on selling on the store. But when I give some away because they're not too expensive to make. They're very expensive to put in a shop because of the fees, because of the organization and so on. But to give away, they're not very expensive. And for other developers, I give them, so yeah, they have it because I have a surplus of defective ones with the labels. And every time I give away one of these, they ask me if it can test USB-C cables. Obviously it can't, because it's only for micro B and not for USB-C, the new standard which everyone is praising. I'm not too fancy about USB-C, but no, it is not for USB-C, simply because USB-C shouldn't have this issue. With USB micro B, it is meant, it is a very easy way to charge plenty of devices with that. The problem shouldn't arise with USB-C cable that gets, okay, here we have a USB-C cable, these cables, because USB-C cables should always have data. There's no reason to put a very fancy USB-C cable and not have data, so you can always use them to develop your firmware and to transfer data. This is what I thought. I thought all USB-C cables have data until I found other ones. I have to find them again. Where did I put them? I have so many USB cables lying around. My collection is huge. Let me show you. The audio should work. Let me listen to it. Does it work? Yep. The audio works. So these, for example, are just USB cables to test. There are lots of different ones inside with different configuration, some with defective, some not. So this is my set to test. This is my set for USB-C cables. And I found out these cables with magnets. Actually, this one is okay. There are other ones. So I found these cables with magnet connectors, so you don't have to plug and unplug all the time this thing, because I find USB-C cables very not as fragile as micro B, but still fragile. So you don't want to plug and replug very often, and you don't want to have dirt inside it. So if you don't want to have dirt inside your connector on the phone, because you're charging it every time up here, you can just plug this inside, so it always stays plugged, no dirt is coming inside, and whenever you want to charge it, you just get the magnetic magnetic connector. And it's nice because the magnetic connector is a lot easier to put. But these cables don't always come with USB data transfer. I think this one does. I already marked it. Yeah, charge plus data plus power delivery. I think I didn't buy one which doesn't have delivery yet, but I know it existed, and I bought the magnetic cables just to test out the different magnetic cables, and there are ones with only transfer, which only transfer power and not no data, and sometimes they don't have power delivery, which I thought power delivery is always included in a USB-C cable. On the magnetic one, it is not. And I come to realize that there are plenty of USB-C cables, and there are plenty of USB-C configuration, because USB-C you have in these cables you have 24 pins. Sure, you have 4 ground and 4 power, but you still have 16 other pins which are there to transfer data, power delivery, and so on. So not all USB-C cables are the same, and this becomes even more problem, because while on micro USB it's always you have charging, you have data, sometimes shield. Here you have so many different possibilities of a cable, and it is not marked on the outside, so you have no idea if this is only for power and so on. And most of the time when you buy a cable, the main difference is, can it do 100 watts, so actually 5 amps at 20 volts for fast charging, or like this one, can it only do 60 watts? That's the main difference I thought there was in USB-C cable. There are plenty of other differences. So this is why I decided to, following to this one, I wanted to build a USB-C cable tester. And this is the first prototype of the USB-C cable tester. So here we have a cable going on both sides, and this circuit here is the most complex one, because, well, the most complex, it's not that complex, but it's still, you try out to figure out if it works. This detects if there is a chip inside the cable. So for USB-C, if you want to have 5 amp capability, or if it's praised to be a 100-watt cable, you need to have a chip inside the cable, and the cables are then called electronically marked, or at least that's how the USB specifications call them. When a chip is electronic marked, it has a chip inside, and the chip will tell if this cable is rated for 100 watts or not. So generally it's just thicker wires inside. It also tells a lot of other different things. It's not only tell about the current capability, it tells about the length, it tells about the USB generation, and so on. Actually I can show it to you. Here there are some USB power meters which can actually show you the capabilities. So I did also a video on this one. This is the WebU2 or QAU2 or VitronU2. It has plenty of names, and actually it's deprecated. I'm not even sure it's sold anymore. Maybe there's a follow-up, but this is at least 3 years old, so there are other ones which are now sold which can do that. And these devices can also, so they can figure out what power delivery configuration is used, but I can also read the PD information. So here entering PD, no PD device, yeah, okay. And if I plug in, okay, it has a bit of an issue. Come on, exit. Here. That was the wrong mode. So let's go in the mode. Yes, I'm sure. Auto detection. No, what we want in this menu is here, eMarker. And yet there. Now this normally, which is just a USB power meter, so it just measures how much power goes through USB. It's also capable of USB-C. It can tell if the USB is rated for 5 amp, and it will tell you which USB data rate it's compliant to. So here this is 3.2 Gen 2. I think Gen 2 means it uses 2 of the 4 differential lanes. I don't remember, or maybe 4 of them. I've never really played with USB 3, so I don't know all the USB 3 different generation, what it means. Here 1 or 2 meter, there's also the vendor and so on. So there are plenty of things which you can use of the in the cable. So in the cable there's a chip. Actually, there could be 2 chips. Most of the time there is only 1 chip, but there could be on either side, on both sides, there could be a chip which tells the capabilities of the cable. My USB-C cable tester will not read the data because you can buy them for less than 30 euros, something like that, from China. So there's no need for that. I want to have something which also works with non-eMarked cables like this one. For example, now I have to clear. How do I clear? Now the data is cleared, and if I put this one in, it doesn't tell anything because this cable is not marked. But for a non-marked cable, I still want to figure out if they can transfer data and so on. For marked cables, generally, you already feel the quality. You see how thin this well, not thin, but you see how thick this one is. They could cheat, but most of the time it means that there are enough conductors in there. And if it's sold for 100 watt, generally it's a good cable. It's for the non-100 watt cable that I'm interested. And this part here is to detect if there is a chip inside here or not. I don't want to read out the chip, I just want to test out the presence. Generally, if there's a chip, it's a good cable, and it doesn't have to, but it is most often rated for 5 amperes. And so this works. This was the most complex parts, else it's just testing if the wires are present in the cable. So it's just a conduction test. Nothing fancy, nothing complicated. So this is done, and then I created let me prepare it. I created the schematic for that. Come on, damn screen. Here, let me switch to. Actually, I can switch to. If I switch to screen, which screen does it show? Bench. Okay, it shows this screen. Full screen. And now it is time to build it. So this is really a hardware build. And I will use these kinds of things here. So these things, I play a lot with USB-C currently, and I've created USB-C breakout boards for male and female, so plug and receptacle. They look like this. Let me get a one which is properly, then I can show you the other ones. This is not a good one. This is not a good one. Yeah, for example, so these are the USB-C breakout boards, and you have all the 24. No, yeah, you have all the 24 pins which are available on this breakout board. You have plug and receptacle, and they are breakout board friendly. So you can, as you can see here on this breakout board, you can plug them in the breakout board and have all the devices available. And you can do a lot of things with testing USB-C. So you could do a gender swapper, male-male, if you have 2 times female, because you can stack them. But actually, they are not impedance control, so I wouldn't do any super high speed. Everything which is USB 3 I wouldn't do without or with it, or something with a display port or things like that. Only for slow device, for slow speed. It's meant just as breakout to test things. If you want to do super high speed, generally you don't know what you're doing and you don't need these breakout boards. I have some of them available. I didn't put in the shop because meh. I didn't have the use. I didn't think there was a use for it. Maybe there will be a use for it. And the issue is because the only I found were these ones. I have two of them. These are the things I found on AliExpress, and they're not breakout board friendly. How? So sure, you can connect all the pins here, but I wanted to have something which is a breakout board which is breadboard friendly. This is not breadboard friendly. This is why I designed these ones. And I use them quite often because on USB-C you have different configurations. So here it's non-populated because you never know what you want to do. And in USB-C you are telling if you are a sync, not a sync or a source, what kind of device, if you're a host or a device depending on resistors which are after the connector. So for example here it's 4K1, I think 5K, 5.1K with RD. It means that I am a device. So this way, if I plug into USB-C, then the USB-C host thinks there is a device connected. And I have the same with, this is RD again. Here, RP, pull up. And this tells that what kind of current, what is it? 52K. It should be 52K, it is 56K. And this tells that I am a host and I'm able to deliver so much power. This is 5K1 again. So yeah, this is why I like this these boards, because I can put the resistors wherever I want it. And I will use these now for my prototype. So I need 2 times receptacle, this one. There's one here. And do I have to build one again? I don't want, because they take so long to make. These are hand soldered. I didn't. Yeah, these are hand soldered. So the one I made, the few I made are hand soldered. So it takes quite a bit of time and fiddling to have all these 24 pins here and all these 24 pins here. Actually, this one is a bit easier, but all the 24 pins here, if you don't have SMD solder, if you don't reflow solder, it's a bit of a pain correctly. So sure, you can solder reflow. So you can reflow solder it if you wish to. I didn't do it. So let's have 2 of these. So this is the breakout board. This is the breadboard, which successfully tested a way to detect if there's a chip inside here or not. We have 2 of these devices. I want a prototyping board. Something big enough to fit both of them. Is this big enough? Yes, this is big enough. 1, 2, and I have enough space for putting all the other things in the middle. So I will use this one to have one which is the one which are smaller, a bit too small. That size which is just under it are these ones. Oh, although it could work, but let's do on a big one, and then I have enough space to work around. And it's nice if the 2 plugs are on the same side and not like here on the opposite side. And here there would be, I could put them here. Yes, theoretically I could. Oh, well, actually it's not too much of a bad idea, because then I can solder directly the wires within. Actually, it's not a bad idea. What I was afraid of is that the connectors here are too near to each other, and that I wouldn't be able to plug the cable. Let's test it out. Here's a USB-C cable. And it's okay. Actually, I can plug the two cables inside, so I might use this to have it a bit smaller. Then I just need the wires in between. And here there's enough space for all the LEDs and all the resistors and so on. So yeah, we'll use the smaller one because I have plenty of small ones, but not a lot of big ones. I like to keep the big ones for the big projects. Although I could just buy more. So let's switch on the soldering iron. Let's get some headers. Takes longer, but it's easier to solder headers on this thing and then on here. I will have a breadboard. So you will only see me soldering things. Might not be that interesting. Where are my header pins, pin headers? Here. And I will use a lot of them. Well, 48 to be exact. Yeah, soldering directly could be done, but it doesn't always work very well. So let's use these ones. And yeah, I want to keep it this way or this way. You see on both sides you have the signals. Actually, this is side A, this is side B because they are mirrored. This is why you can flip. The connector is reversible, so you can flip on either side, and then based on where the resistor is, you remember I showed you that you can have resistors depending on where the resistor is found on the other side. They know the orientation of the plug, of the cable, and the orientation of the USB-C. And whenever you want to solder something like dip or something with pin headers, well, at least a small trick is to solder them on a breadboard. This keeps them very parallel to each other. See? It's parallel, and this way it's holding tight, and I can solder on it. Where is the solder? Here. Solder spool. And let's solder the first one. You even have the shield contacts on this one. This is not placed correctly. I'll have to cheat a bit. See, I didn't pay attention. And now there's a slight bend, but I'm not doing USB-C transfer. I don't care about this small bend. So I said that it is not meant for USB 3 because it's not impedance controlled. So very probably there's a super high signal degradation, but at least what I did is lens matching. So the differential pairs for USB 3 and USB 2 are lens matched. That's, yeah, an overkill, but I wanted to try. I wanted to try to do lens mathing with the tool I had, and it's okay, it works. It's not as easy as with super high fancy EDA suits like Altium, but it works. I'm using PCB-RND, if you're wondering. PCB-RND is the CAD for board layout I'm using. Yeah, it doesn't look nice, but it will work. Actually, I've even built a tester for these things. I can't. I'll show it to you on the other one because now it's soldered. I cannot test it anymore when it is soldered. Yeah, 24 pins. Actually, there are more than 24 pins because I have 2 times shields. So in this one, there are 25 and 25 pins. Up. I need another row. Up. I think I will need to buy more of these things. So how do I test it? I built a tester which is here. This is my tester for, so whenever you build something and you intend to have it mass produced, or you want to build more than 5 of them, build a tester. It's worth the time. And this tester will check, but I need the other side, if all the boards are, all the pins are soldered the right way. I told you it's a bit hard to solder correctly without any issues, and it is still possible, but where is the second part? I need the second part so I can use the tester, else the tester will not work. I can't find it. Why can't I find it? It must be in there. Did I put it somewhere else? No. Here. These are my testers. So what it simply does, it bridges one side to the other side. So the side A to the side B. And yeah. So here they are the LED. Here, when I touch that, it means there's something wrong. Well, I'm shorting, so I'm shorting 2 of the pins. Now, how do I test? Here there are pogo pins, so spring-loaded contacts. Now what I just need to do is, you can see if I do it next to the cable. So I press the pogo pins on all the pins, and here it tells me there are some which are right. So probably the ground pins up. See, if it's blue, if it's red, it means there's an issue. If it's blue, it means it's correct. Some are okay, and I think the ones are okay are the ground pins because they are connected. Oh, the shield. Yeah, it's the shield, which is, you see, whenever I touch the shield, there's an issue. Well, the shield pins are connected, and now if I plug my tester, which is just a short on all these sides, it should be green. Green. It means that all the things have been soldered correctly, and this is how I know that I've soldered this thing correctly. Yeah, quality control on products. Now it would cost a fortune to make this because of the chip shortage, but this tester was expensive, and I hope that in 1 or 2 years the chip shortage will decrease a tiny bit, because it's impressive how expensive the parts have gone. Slightest microcontroller is super expensive, and this is why I had to switch microcontroller. I designed everything with STM32. There are no STM32 parts available, or for at least 10 times the price they were before. And even the cheap ones, like for example the $3 microcontroller from Paduk, there have been now 30. No, not $3, 3 cents. Now it's 30 cents at least. And it's crazy. And they're not available. So I had to switch microcontroller, and I used one which, so now I will tack the 4 corners, and this way I'm sure that at least this is level on the 4 corners. Now I can solder, afterwards I can solder all the ones in the middle. So yeah, what I was telling is it's impressive how high the price come. And I switched microcontroller. I like STM32. I'm really familiar with STM32, but because there's no parts anymore, I switched to ESP. I don't care about the VLAN, but the microcontrollers are available and not too expensive, and they're quite impressive actually. I always hated the ESP parts simply because most of the people who use ESP parts just use them because of the Arduino support and library support and make crappy code. And I don't like the Arduino environment with layer on top of layer and nobody knows what is in the back. But I started actually I like the ESP devices. They're well documented and the IDE is fine. No, I'm okay with it. I was a bit surprised. I didn't think that it was that good, and now I can also somehow praise it. Although it's not perfect. The USB stack is far from perfect. Up one, two. So yeah, I'm developing projects with ESP now. But they don't answer everything. There are some projects where I need more than those couple of I/O it has, or where I need 5-volt tolerance I/O, which ESP doesn't have. It doesn't have a lot of I/Os, and it doesn't have 5-volt tolerant I/Os. Else it has plenty of things. Let's solder these things up. So now I'm again soldering all the legs. Up. I could trim the legs, but this way I can also still plug Dupont wires on it if I want to test or have probes. So with the multimeter or with the oscilloscope. So I will not trim them. And it's really just a prototype to know if my schematic is okay and if how I think works. If it is done, I will test some USB-C cables. I'm sure I will find configuration I've never heard of or I can't imagine. But yeah, I can still iterate. At least I can make it that it works with all the cables I know. And the USB-C specification, USB-C specification only lists 2 cables, the full featured one for USB 3 and which is mandatory to have electronically marked, and then the standard cable, or the USB 2 cable. I think they use both terms in the specification, which is just there for USB 2 and for backwards compatibility. Most of the time this is useful. This is enough because they can also be used to charge at 60 watts, so 3 amperes. They are rated for 3 amperes, and USB-C allows you to have 20 volts on 20 volts on the VCC line after negotiation. And the negotiation is between the device and the charger. And actually, you might be impressed by, for example, I haven't seen any phone which uses 20 volts. I've seen phones which use 12 volts, 15 volts, but I've never seen a phone which is 20 volts. And the laptops, they use 20 volts to charge. Not always, but sometimes they use 20 volts. I don't know why sometimes, although I have a 20 volts capable charger, you not think anything, I have a 20 volt capable charger, sometimes it still uses 15 volts. I didn't figure out, and this is yet another project I want to test. I'm building on, but this is for later. Today is about USB-C cable checker. So here we have all the pins soldered. Do I want to print? Yeah, I will print the schematic. This way I can check off all the connections I've done. So what is this arrow? I don't care. Boards, USB-C cable tester, schematic.pdf. Printed, yes, printed. It has even more LEDs than the Micro B. So, where is this device again? This one. Here you see I have 5 LEDs already for power, data, shield, on the go, which I think it's a dead technology, but it's still there because I could. And then battery charging, B charges battery charging. And actually, if you want more information, just scan the QR code. And I need, so these are 5 LEDs. I found 5 different colors, and now I need 2 more LEDs. LED colors. Oh, it's visible. It's not very, no, it's okay. And I will use this to check the pins. Up. So yeah, and I didn't find, so these are 5 standard colors: red, green, blue, yellow, white. And there are, no, actually this is the white one, this is the yellow one, but other ones are a bit harder to find, they're a lot more expensive, so I will just reuse colors, I think. It's not finished, the design yet. So let's test with the power pins first. I have to short all the 4 power and all the 4 ground pins. And to short pins, I will use resistors. With plenty of, I will keep them. Let's use resistor I have plenty of. 100k resistors. There are not plenty here, but I know I have plenty of 100k resistors in my collection of resistors. Resistors through hole for part assembly. Up. All of these are just resistors. Or through hole resistors for projects. 100 ohm, and here on the back there should be, oh, I have even 1 mega ohm. Okay, this is the max. This should be 100k. Is it written on it? I should have written on it. Oops, sorry. Here, 100k plus or minus 1%, and I will use these as wire donor. Up, yeah, wire donors. They're easier to solder. You just have to pay attention not to short them. And yes, I keep everything in ice boxes. It's the most reliable source I found for boxes, which will still exist in a couple of years. And you can build up over time. So, the ground pins. These are the ground pins. Luckily, they are in front of each other. So, no, don't do it now, because else I will have issues cutting it. Side cutter. Or flat cutter, I'm not sure what the actual name is. And probably, although no, not with this microphone, but I couldn't record videos the last few days, weeks even, because they are doing some renovation work in the building. And there's nothing I can do against that, except record very late. But yeah, you hear hammering and drills all the time. Up. And I did something wrong. Although these are the shields. That's okay. Shields should also be shorted. So it's nothing really wrong. So yeah, you see, these resistors are very cheap and they are good wire donors. And the camera is again not in my view. I need to have a holder. Hup. It gives a bit of rigidity. Up. Up. Okay, one resistor is done. 10k. I'm not sure what the 10k's are. What is this value? This is probably 100k. Are these the same color? No, not the same color. Not 100k. Probably 1k. Let's test out. Wrong one. 100k. Oh, 100k, but it's not the same colors. But it is 100k. So are these also 100k? 100k. Okay, I don't know how to read colors. I don't know how to read. I really don't know how to read resistor colors. I'm used to SMD resistors, but here I have. There are three. Okay, here it's brown, black, yellow. So brown is 1, black is 0, yellow is probably 4, and then golden means 5%. Here I have brown, black, black, orange, and orange. So 1, 0, 0, and then orange is 3, and then the brown on the back is probably the precision. Okay, so this is 100k. I will put them in 100k bag. I will not use any 100k in this project. No, I don't. Up, micro USB cable tester. So then we have VCC. I think VCC, let's have a model. I think VCC is here. 1, 2, and then VCC. Up. 1, 2, VCC. And I'm shorting the. I shouldn't have to short. Well, shorting the ground lines of the USB connector is not really mandatory, because while you have 4 pins, you only have 1 ground and 1 wire, 1 power wire in the USB-C cable, and then all the connectors are interconnected in the plug. So I could use any of the 4 ground or any of the 4 power pin. And in an ideal world, the USB-C cable tester would test individually all of them, but for that I have another device, which I probably never I did a presentation on it. I don't know if the presentation is public. Where is it? Where is this project? USB-C cable tester. Here. To really test all the connectors in the wire, I've built this USB-C cable tester. USB cable tester, and this tests all the variants of USB. You have USB-A in 3.0 version, USB-C, USB-A because sometimes you have Y cable or USB-A to USB-A cable, which is not standard, but it still exists. This is USB-C with the 5 additional pins for USB 3. Then we have USB Mini B, Lightning, but actually I don't use the Lightning. I just put it because I wanted to try it. USB-C, because you have USB-C to USB-C cable, or USB-A to USB-C, and then Micro B in the 3.0 version, where they added the 4 additional pins on the side. And this device can test. Well, does it work still? Whew. It's been a long time since I used it. But this device can actually test each individual pin of the cable, and it can even read the PD information, like I showed you how this reads the electronically marked cable. Well, this device can also read electronically marked cable. Is there still power on this? So battery, yes. Plug-in cable, it seems to work. I like this old-fashioned LCD screen. They are very easy to read, they're cheap, they're easy to drive, and most of they're easy to read. And it doesn't work. Normally it should have detected that I plugged something in. USB cable tester, plug in. So maybe it doesn't work anymore. I don't remember what the status of this project is. No, it should work. That's weird. Let's test with the Micro B cable. And it has a huge database of cable, and it tries to detect which cable you did plug in. Okay, no, the code is broken or something is stuck. It shouldn't. I modified the code so I only read here. It does. Now I remember. I've modified the code so it doesn't test automatically and puts out the result here. It does it over the micro USB port, because you can actually also connect it to the computer using the Micro B, this Micro B, so to flash it, but also to read the exact results, which wire has an issue, which wire is okay, and then testing and debugging. So let's try with this one. Maybe I have 2 of them. I only have 2 of them. Let's test with this one here. Let's see if this one works. No, same state. It doesn't. Although here it is now. This is charging. Nah. Same code status. It doesn't test automatically. But what it should do is actually test automatically all the combinations, and then it will tell what kind of cable it is. And I will have to update this device and the database, because this doesn't include the magnetic USB charging cables, because I didn't think they existed. So in USB-C, I only put the full featured and the standard cables. So once at some point, I want to redesign it to be in a better case, because this is ugly. But chip shortage. This chip, I can't find it anymore. And I need this super large chip, which is 144 pins, because there are plenty of pins, because there are plenty of connectors. So you see, 24 pins, actually 26, because 25, because you have the shield. 25 pins, that's already 50 pins. Then I have here 16 pins, no, 4, 5, 9 pins. These are 9 pins, 9 pins, 10 pins, and here we have 6 pins. So you see, it's going fast, and I need to really test individual other pins. And no, I cannot use shift registers, because the shift register don't allow me to individually control the individual switch on and off, or put each individually the pins floating. Or at least I didn't find any shift register which allows me to put some floating. Generally, it's all on or all off, and I can use all on and all off. This is why I need such a huge chip. The code is simple, but the code is simple. Still a huge database. Oh, 2019. So yeah, this is at least 2 years old. Yeah, it's around 2 years old. You can find it if you want to build yourself. I would recommend. There was the link. I think it is still up. You can find the sources if you want to build it yourself. But it's not really completed, and I really want to build a smaller form factor. Up. And yeah, I've tried with two screens. Here you see the LCD screen, the easy LCD screen. I want to keep it because it's really readable. I tried with blue and green because I thought blue looks cool. It looks cool, it's not readable. Green is a lot more readable. So I will keep the traditional green, which you see everywhere. It's old school, it's old fashioned, it's not a super TFT LCD, but it works. And I also tried with the mini OLED display, and now it's switched off because it's too small. You can't see anything. I want readability, I want to have something readable. This is readable. But it doesn't work anymore. This is a project which I need to start. I will continue once I need it again. Actually, I could need it. Okay, so let's come back to here. So this is soldered. Then we have ground, which is also here. So I cannot show you that actually the tester tests all the pins, and this tester is a lot more extensive because it tests really all the combination, all the connections. Well, this tester, the one I showed you, the USB cable tester, not the USB-C cable tester. The USB-C cable tester will be very basic, but for 90% of the time, if you're not producing cables or if you're not playing with cables, you're just buying cables, it's sufficient. It will tell you what type of cable you have. It will not tell you if it's 100% perfect, the cable, but it's good enough. So I think it's here. Let's check again. 1, 2, and then VBus. Yes, it is. Not sure what they're doing outside, but the whole building is vibrating. There must be some very large motor running, some industrial machine or some construction engine. Or some generator. But at least I still have power here. Up. Audio seems to work. All the cameras seem to work. I think it will take all day. So we have all these connected. Now this tester is to test if it has power. I forgot about that. Where will I put it? It needs to be powered. So I should still have some of these connectors. Yes, here. Up. Think about it, but yeah, this is quite large. I will put it in the end once everything is done. Or I can put it on the side, like this. Doesn't look nice. So yeah, I will put it in the end when everything is done. I don't have to solder, so I can have a portable device. For now, I will have the power coming from the side. So here there will be 2 pins for the power. Let's solder a 2 header pin here. Up. Yep. Here. Up. I will burn my fingers if I hold it this way. So let's use some tweezers. I could even have it this way, but it's not readable. I want everything to be from on the front. And I'm not lacking. I don't have to optimize it yet. Ah, come on. I'm not able to solder some pin headers. Okay. 1, 2, let's fix this one. Ah, I didn't wait until the other one was soldered. No, it's okay. And I will immediately mark it. A marker. This will be minus. I like to have minus on pin 1. And this will be plus. This is just my taste. And we will have 3 volts. It looks like a 5, but it's a 3. This will be a 3-volt device. So, the first cable and LED. The first LED is a red LED, and for the red I used 1K. 1K resistor and 1 red LED. 1K resistor, and I will use a huge red LED. Here my LED box. And I will use one of the huge ones. Although, how many LEDs? I need to have 7 LEDs. Can I have 7 LEDs next to each other? It would be nice if they would be all somewhere around here. Let's try if I can have all the 7 LEDs. I have 1. I actually red, green, blue, yellow, white. 5 colors. Yeah, so yeah, these are the standard 5 colors. Red. Yeah, I think they will fit. 1, 2, 3, 4, 5. No, only 5 of them will fit. But even with the smaller ones, I will not save so much space. No, I won't. So I can still keep the big ones. But they will not all fit this way. I can only fit 5 of them this way. Can I fit them this way? So yeah, on LEDs, generally, most always the long leg is the anode. This is the plus. This is the cathode. This is the minus. And on the minus, you also have a flat side on the LED. Can I put 7? 1, 2, 3, 4, 5. No, it's also only 5. This board is a bit small. I will have to put 2 rows. 1, 2, 3, 4, 5. Yeah. 1, 2, 3, 4, 5. And actually, I will need to put 8 LEDs, not 5 LEDs. I need to put 8 of them. So yeah, I will put 5 of them this way and 3 of them this way. Let's start with these ones. Yeah, I need, because of the circuit on how I detect the how is it called? Actually, let's put it on the electronically mark, or the PD wire. I need to do it. I need to have 2 LEDs to detect the CC wire. You will see everything when you read me afterwards. Once the product is published. It is not yet, because it is not completed. I don't publish it until I have a first produced prototype. So, how is this LED put? I think it's I shouldn't have put it here. Either way, not bothering now. Up. No, it's going to ground. Yeah, so it's not important if at least on this, for this one, it's not important if the resistor is on the anode or the cathode. On most of the LEDs, it's not important. On some LEDs, it is. In my project, at least. So, I have I didn't think about it. Let's not put it on the side because they have no control over it. Oh, I don't have it on the other. I don't have it on the back side. Let's put it on top. It looks nice on the side, but it's not very useful. And it's gone. Oh. So, some isopropanol and erase the marking. Yep. Some earbuds. Where is my marker? Yeah. This is minus, this is plus. And we still have 3 volts. Okay, so I need the plus wire. There will be plenty of pluses going from here. So let's use some cables. So I use this silicon wire box. They're quite nice. Hup. And yeah, as you expect, most of them which you use are red and black. So plus do I want to solder it? Yeah, we'll just solder it directly on here. There will be plenty of pluses connected to. So at some point I will need to bridge. Oh, actually I can bridge now. I can make a plus bar. Up, let's make a plus bar. All of these pins will be plus. One. So now I can re-put it, I can put it back here. Because the LED and the resistor are there. So, up. This will be my bus bar for plus. Alright, rail. Let's call it a rail. I think rail is a nice name and it's probably the most accurate name. And this is why also the resistor legs are useful for. Up, it's holding. Up, so we now have plus and minus. I will also mark it on this side. Dun, dun, dun. That's how you do prototypes. I could already have it. It's probably as fast to draw it in a CAD layout, ECAD, PCB layout, than what I would do to building this, but then I need to send it to China or to the production factory. It will come in only 2 weeks, and then if I have mistake, then I have a 2 weeks rollover. So it's not ideal, and this is why prototyping like this is nice. You could also produce PCBs at home, but no, I don't want anymore. They takes too much time, and I can't do it anymore. It's too hard to make it two-sided correctly, and yeah, I don't produce PCBs anymore. I don't know anyone who makes their own PCBs anymore, produced from copper clads. Too cumbersome, and this way I can still, yeah, these prototypes on these kind of perf boards are perfectly fine. So I need to connect it to plus this one and this one. So we will have it on, so this connector, yeah. So this connector will be side A, this connector will be side B. Let's put it on side A. Where is my side cutter? Yep. Up. 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 On this one too, although they're interconnected, I shouldn't have to, but I want to do it properly, like I did some mistake here. I should have cut it before. Let's try if I can do it. Strip isolate. Let's strip isolate. Let's desolder this one. I want to strip here this way. Not really. More like it. Up some wire, some solder. Okay. And you see, because it's silicon wire, not PVC coated, PVC plastic, I can hold a soldering iron for long. It doesn't burn. And it's a pleasure to solder. So plus plus, they're all connected now. Then the plus goes to the plus on this side, which goes to this LED. This is the long side. The long side is the plus, so it goes in here. Up. So let's prepare the wire. This is not well soldered. Plus. Then we have it somewhere here. Up. So this is the plus going through the cable up, and then it goes to the plus, which is here. This cable I don't use anymore. Up. Up. Here. Now, okay, and then this goes to the minus, so anode goes to a cathode, then the resistor, it goes to ground. And actually it is long enough, but I shouldn't do it. Bad idea. I will put a black cable, so this, do I want black? To show that this is ground, yeah, we'll use black for ground. Black wire. Since I have no viewers and my channel is completely unknown, I cannot interact with you because there's no you, there's only me. Black, it goes to this one and this one. So, sorry, and this one actually. So it goes through. So goes through one connector, goes through the LED, and back to the other connector. This and somewhere. Oof, this is a bit too much now. It's okay. One, and let's thin this wire. And I need to fix the first one because it's just temporary. Okay, let's fix this one. Okay, that's the minus on one side. Then we have the cable going back through the cable to the other side and then to minus, and I made a mistake because this should be plus and this should be minus. So this is the other side of the cable. And actually also it is yesterday or was Chinese New Year or Chinese New Year. Most of Asian countries celebrate this lunar year or solar year, lunar year. I think I don't remember exactly. Not too knowledgeable about Asian culture. But yeah, Chinese New Year is currently running, so it means that even if I will send to a PCB fab, it will not be produced in the next week, something like that, and then they will have a lot of backlog. So let's spend some time and test it this way. Ooh. Okay, this was not where I planned to do it. This way. Yes, because if I do prototypes, I'm not using a fancy fab house, using one of the cheap ones. And they are all in China. For more professional work. And when we do super high quantity, well, I don't produce that many boards, but I worked with a company producing many boards. You use European ones simply because generally the quality is higher, but that's not the issue. They have a contact. So if you have questions, it is fast. You call them or you send an email, and they know what they're doing. They're right professional. Try to get some service from one of those cheap Chinese PCB fab houses. None. You always have to argue for hours for an issue you shouldn't have to argue for. But yeah, you're not paying for customer service. So what do you expect? So this should work. Let's cut the leads. Hold the leads while you cut them because they have a really springiness and they could land in your eye. So I have my this is the wrong one. Which is the one which has the female cables? This one has female, well, Dupont wire. Okay, it's the right, yeah. You also see the dashboard. On the dashboard, you will see when I connect it. So we have plus, we have minus. It's limited to 50 milliamps, which is plenty enough. It is 3 volts because I will use 3 volt coin cell. And yeah, it draws nothing. Well, it draws 1 milliamp, but that doesn't count. It's more measurement error. 2 milliamps? Well, nothing should draw 2 milliamp. Maybe just a measurement error. When it's so low, or some tiny leak. Now if I plug the USB-C cable and the one which I always lose, let's plug this one, we should have a red LED indicating that it is capable of carrying power. And we do have a red LED. So the first thing works. This cable is capable of power, of delivering power. Okay, so let's use the sheets and let's remove. Let's cross out the circuit which I made. It's this one. Power, this is done, VBus. So I don't need this anymore. I don't need this anymore. This is done. This is done. This is done. The next one is shield. And for shield, I used white LED. White, it is okay. Yeah, white is fine with shield. White, and for white, we have 1.5K resistor. Do I have 1.5K? I have 1K. Do I have to look at my assortment? I do have an LED assortment. Yeah, I will use this. So here's my box of LED, sorry, power resistor assortments. This is my box of resistors, and within there I have all types of resistors, power resistors, nichrome wires. These are heating. Yeah, and I have a set with plenty of values inside. I will use this. And there should be 1.5K or something like that. And they have markings which are almost not readable, but they have markings. I have 2K and I have 1K. Come on. No 1.5K. In my set, do I have 1.5K? Resistor 2. 1K. 2K. No, I don't. Let's use, and here 3K? No, let's use 2K. Which one is it? I have SMD LEDs with 1.5, but I don't have. It's 2K. I could put in parallel to 3K. 3K3? No. I mean, it's just a prototype. The value, and even the LEDs are not the same, so the values I used for the resistors are ballpark measurements from which I got from my micro USB cable tester, which so they have all approximately the same brightness. I didn't measure it with some brightness calculator, some brightness measurement device. I do it by eye, and by eye with these values the brightness are almost the same. So we will use, is it this one or 2K? Yep, let's try it out. I know what did use 1 milliamp. I had the breadboard with the circuitry which are still connected. This one had also LEDs. This is 2K, yeah. So the shield is quite easy. It goes direct, wrong side. I have to put it this way, so the minus aligns. Up. And now this will test the shield. And I don't have a white wire, so I will use yellow. Resistor. Again, I don't care what is connected, which side the resistor is connected on for this one. What would be nice if to have it under. If I could sneak the resistor leg under the cable so it looks a bit nicer. Won't change any of the functionality, it's just for my eye pleasure. Okay. So the top always minus. This needs soldering too. But not on minus because. Although how do I do it? Yeah, the plus goes on it. On the LED, so the plus goes here, then the minus goes to the shield. Okay, so we have the plus. We will still use red. Yeah, we'll still use red. Up, this I can remove. Where is my holder? Yeah. Up. Plus. I should have put this one here so it's not in the way. Up. Plus. I'll also put it here. There will be a lot of pluses. The plus goes to resistor. Right? No, to the LED. This is the plus leg. Side cutter. Wire stripper. Tin the wire. Up. So the plus goes to the plus of the LED. That's done. Let's cut the LED legs. Resistor leg. And this goes, so this goes then to the minus through the LED, through the resistor, and the resistor should go to the shield. And we decided, actually it doesn't matter. It doesn't really matter. For the shield, we will use yellow. If I wanted to do like the schematic, it would have to go on this side. Well, let's do it like the schematic. Up. So second LED leg, LED resistor leg, and you will sneak through both to go here. Yeah, we'll do it this way. This is one side of the shield, and if you're wondering how you connect the shield or USB specification, at least for USB-C, for all the other, I didn't see any recommendation because it is very application specific. But in the USB-C specification, I've read that the shield should simply be connected to ground on the connector. No capacitor, no resistor, no side. It's on ground on both connector sides. Point. That's all. So goes through the first one and then goes through the cable to the other connector. Extend the wire. That makes it an easy design. And I haven't seen any measurements, but I'm also not RF. And this goes to minus. So it goes all the way here to minus. I'm not EM specialist, so I don't know what best values would be for capacitance and resistance. There are tons of guidelines and everyone does it a bit differently. Probably because everyone has other requirements and other specificities. That's possible. I would still love to have the two wires. No, we can test it if the shield LED works. So minus on top, plus there. Now this cable. If I connect the cable, I should have the red LED for power and the white LED. Oh, yeah, you see? The white LED is on. It is a bit dimmer than the red LED, but it is still white, and it means that this has a power and shield. And I will mark the LEDs. Blech. Marking on here will be a pain. I will mark it in the end. Now let's mark it also here, but I will put some tape afterwards. This is power transfer. This is shield. Yeah, we'll put some tape afterwards. There will be 3 more LEDs on this side. So let's use the paper. And the shield, it's this one. This is done. Shield also here. This is done. Next one, I think I will be USB 2. Is there something important? SPU, now that's afterwards. Let's make the easy ones first. USB 2. So, USB 2 are a bit more specific, are a bit different in cables. For USB 2, you have 2 pins on this side, 2 pins on side, 2 pins on side A, 2 pins on side B. The same on the other side. But you don't have 4 wires. You only have 1 pair of wires. And actually, it is up to the whole PC or controller to figure out which one of the sides is actually for the USB. And it can figure out using the CC wire. Another trick, if you don't want to figure out, because then you need some intelligence and some switching, is simply you bridge the wires together. So the 2 D plus, D minus on one side are connected together. That's the easy part, and that's not how I do it, because, no, this is how I do it. Yes. Yeah. Oh, actually, whoa, how do I do it? Yes, this is how I do it, because there's only one thing. So the plus, D plus, so being on one side or the other, is VCC, and D minus is ground. For data, we will use, which LED did I use? Green, yellow, green. So we will use green cable. Yeah, use green for USB 2 and blue for USB 3, I think. Green USB 2 and blue USB 3. Yeah, that's it. So green will become plus will need to go on 2 pins on one connector. I should put the LED first, but I can put it afterwards, so we can switch tasks. In between, green plus is here. Green is plus, and it needs to go on D plus, which, oh no, this one is, yeah, this one has an issue. But this is the first prototype. I hope that, where are they? The other boards don't have the broken marking. I think this is version 1, and I already did a version 2. Yeah, version 2, and this is fixed. Yeah, D plus, D minus, D plus, D minus. Yeah, it is fixed. Is it fixed on both? D minus, and on the other side, D plus, D minus. Yes, it is fixed. It's just on this one that it's broken. But which one is, we are here on the receptacle, and the receptacle D plus is just below SBU. A7, is this right? It is not written. No, it's not just below. Oh. SBU1, SBU1, D minus, then D plus. D plus are on the same side. Let me check my USB-C diagram. No, I have a mistake, but do I have the mistake here? So according to my USB-C connection next to SBU, there's always D minus. SBU, D minus here. SBU D minus. But why do I have SBU on both connector on the same side? Did I want it this way? Huh. Well, next to SBU is D minus. This is SBU, so this is D minus, so this is D plus. So it means that on the other side it's also D plus. Okay. Ah, yes, because I do it on the, you see, here they go in this way, and here they go also this way, so they are inversed. Yes, they are. This is why it's always D minus, but we will see if it works. So we have V bus SBU minus plus. SBU minus, let me check the USB. Yeah, it's SBU minus plus. So it goes, and then we have CC and V bus. So it's this one. And the one in front of it, it's this one. Let's put up these. Let's get it here. Let's put the notch somewhere here. And it's on top. That's the minus, that's the plus. Yes, because we're on plus. Up. Okay, that's D plus on one side. It's not very well soldered, but and this one is far too long. So let's solder it correctly. So it holds. I will have to remove it because I didn't put the LED, but at least it is stable for a couple of seconds. Up. Tin it, so it's easy to solder, and then solder it. D plus. That's one side. Put LED, green LED here. Green LED. For green, I use 2.2K. I have 2.2K here. No. I did have 2k in the resistor set, but I also have 2k in my through hole set. So let's put the 2k from my through hole. That's 1k. That's 2k. That's 4k. Let's mark it. 2k. 2k. Up. Insert the LED. Flat side on top. This one. And I put solder on it so the hole is plugged. Yep. It doesn't fit. But it is it the right side? Yes. It should fit. Maybe it will fit with a bit of force. Not ideal, but it fits with a bit of force. Up. One leg. The other leg, and the 2k resistor is this one. Should be 2k2, man. Well, 10% margin, that's okay. Particularly for prototype. And now I won't be able to put it on the up. How did we do it? We did always connect this side. Which is minus. So we have plus going here. It goes here, and then it goes through this side. Then it goes through minus, okay. Oh, this is the plus, so it goes here. So green wire. Green wire comes out of the plus, so it's same side. You're holding in. Stin it. And since it's D plus, it should be the same. One somewhere here. Is there some kind of plier? Or do I have to build one? Oh, I could build one. Actually, I will try it. I will build a side cutter. Let me make this tool. Do I have a broken side cutter? I thought I did. Let me have a nicked side cutter. This one is in bad shape. It's good. Do have another which is in bad shape, which I can reuse. Not bad shape, not bad shape. I think I threw away all which are in bad shape. This one, is it in bad shape? No, it's still, although it is nicked. This one is in very bad shape. No, let's use the one which is nicked. So I have plenty of. So these are not expensive. I think these are $2 or something like that. And I will modify it. So actually, I can use it to strip it. But these one are nice holes. But I want to use the capability of stripping using this one. So I will file. I'm not sure if I will be able to. Let's file using a square brush. Oh, actually, I can. Oh, but it won't cut anymore. Yeah, the edge will be gone, so it's not ideal. Will it still work? Let's try. Let's try without filing. Let's just try to be very delicate. Or I have to simply cut on something hard. Some steel which is quite hard, and then it nicks it. Okay. No, it's doable with just a side cutter. I wanted to make a wire stripper just for this cable, which is not big, so I can go in there. Up. Minus minus, D plus D plus, it goes through the minus of the plus of the LED, which is here. Let's remove 1, 2, 3. There's the plus of the LED. Strip it. Let's thin it. Let's solder it. That's the plus. The wire doesn't look very good. It's a bit too long. Do I make it shorter? Do I care? That's okay. Then we have again, so it goes through the LED, then through the resistor, and then on D minus. So let's thin the cable because I don't have access to the resistor. Too many cables. Yes, it holds. This, so D minus is this one. And then it goes through the minus. This way. So minus minus and here. Let's use another method. Let's try to strip it and solder it in where the cable is. I'm not sure if it will work, but I want to try it. Else soldering is boring. So we will have one here somewhere. Okay. That's one, then one here. Actually, I can cut it here. Yeah, I can. There will. Up. Tin. Come on. Need to strip it a bit more. Okay, minus minus. This one, that's minus. Oh, I'm getting good at stripping with the side cutter. Up. There's not a lot of solder on this pin. Up. And the cable is too long. Yeah, not too much of a problem. This is, so I need to strip it. Oh, yeah. Okay. This is a lot stripping, but at least it will be easier to solder. And it was. And this should work. So let's test it. Up. Plus, minus, cable. Up. So yeah, shield is already blinking. And I made a mistake somewhere. Because my green LED is not on and this is USB capable. Where did I make a mistake? What if I turn it around on one side? No. If I turn it around on the other side? No. But there's also no short. Okay, so plus goes to here, plus, plus. This must be plus. Voltage meter. Let's figure out where the problem is. Wrong probes. Those are the right probes, at least one of them. Where is my ground probe? Here. This is the ground probe. So here we have 0 volts. Okay, 3 volts. It's going to let's put the 0 volts. What is this? Okay, this is this. And where does the second one go? No. Okay. Okay, so now ground is connected. Now I could measure more easily. 3 volts. Okay. Ah, wrong one. Here should be 3 volts, yes. Then it should come here, yeah. It comes here, goes through the LED, and there's something wrong with the LED. or with my soldering, because out of the LED I get 3 volts. There should be a voltage drop. Ah, no, there's no voltage drop. If I measure here, I also get 3 volts. Here's 3 volts, here's 0 volts. So yeah, there is something wrong with my board. So this is disconnected, but here there should not be 3 volts, but there should be 3 volts here. There is. Okay, so there's something wrong with my shields. Let's check again. Let's get a fresh board which is not yet soldered. This one. So yeah, this one with is 2 times D minus. So there's something. So normally on the connector, D minus and D plus are flipped. The numbers are correct. A7 should be D minus and A6 should be D plus. A6 D plus, yes. So that's correct on this side, although the marking is not correct. This is D plus, A6 is D plus, plus. And then on the other side, a B6 should be D plus, B6 should be D plus, B7 should be D minus. Yes. What did I do wrong? That's something I don't understand correctly yet. So my marking is wrong, is it? The marking on my prototype seems to be wrong. This is plug, this is receptacle. Yes, the marking is wrong. You see, I did put B1 to B12 and here A1 to A12, but actually this is A1. B1. Yes. Wait. Other way around. B1. No, it's not. It is wrong on both sides, so it's symmetrical, so it shouldn't be a problem. But it's so if this is 1, on the opposite side it should be 12, and it is, this is 1, the one which is connected to this pin. No, it's right. It is 12. So this pin on the complete left is connected to A1, meaning on the B side, which is on the bottom side, where the traces are on the bottom side, it should be B12. And if it goes here, it goes to B12. So this is correct. Although this should not be A1, this should be A12. Because this is, although, Oh, no, 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 I didn't, I looked it wrong. This is the receptacle, so this is correct. This is ground. So what is wrong? Is D plus not going to D plus in the cable? Let's check it out. Do I have a second one? Here. Luckily, I still have 2 of them. It seems I need to produce more of them, but I do have. So, let's test it out with the multimeter. These are the wrong ones. So, A6 is D plus, right? Plus, plus. A6 is D plus. I have a cheat sheet in front of me, which you can't see. A6 is D plus, yeah. But the cheat sheet, I'll show you actually. You will also have a version of TAC. No, not VLC. Here. USB-C. It's faster to do it this way. You see, this is the picture. This is the receptacle. Up. Now you understand what I... Up. This can be go lower. Yeah, measurement. So you see, this A6 is D plus, which I got wrong on my version 1, but the pinout is correct on this one. This is A1. This is the receptacle. This is A1. Yeah, the pinout is correct. So I didn't understand something in the cable. Let's try ohms, the beep tests. So in the beep test, does it? No, it's not the beep test. Now it's the beep test. It should be either on, so this, I don't know if the D plus is on this side, on the A side, on the B side. We'll figure out. D plus, it's not on the A side, it's not on the B side. Here. So yeah, D plus goes to D plus. That works. And then D minus should go to D minus. So I don't know what I did wrong. D plus on D plus, D minus on D minus. If I flip it, if I flip the cable, on this side it is still the B side, and on the other side should be the A side. So this is the B side, and now on this side should be the A side. Yes, D plus, D minus. It works. So I have no idea what's going on with this tester. Is the LED working? Let's test up. Let's put a multimeter and test. So this should be plus, this should be minus, this should light up. Yeah, the green lights up. So the LED is working. Plus goes on D plus. Okay, let's figure out. So D plus, this is plus. Then we have minus. Minus. Okay. So here it should be, let's connect ground back together. Is ground. Let's measure voltages. And you don't see any measurements anymore. Maybe the USB broke. I don't know. Oh, interrupt. Select interrupts. 38 in my scripts. Okay, I don't know what happened, but let's start again. So now you see the voltage up. So here we have 3 volts. We don't have 3 volts. We don't have 3 volts. Why don't we? Oh, I switched plus and minus. Luckily the LEDs didn't break. So here we have 3. Come on. Okay. 3 volts. 3 volts. Going to D plus, right? Yes, this is D plus. Is it the right one? Is it the right pin? You see, well, I need to fix the marking because this is plus. Again, plus, plus. So here we have D plus, we should have 3 volts. We have 3 volts. And here we should have nothing. Nothing here. Nothing here. So here we have 3 volts, here we have 3 volts, but we don't know which part, so that's okay. So now if I plug the cable, where's my USB-C cable? Have you seen my USB-C cable? Here. If I plug this, I should see 3 volts on either this side or the other one. This is plus. Yeah, I see 3 volt on plus, on D plus. So this is fine. Now if I connect here, so 3 volt here. 3 volts, yes. 3 volts. But I shouldn't see them here. I don't. And I do. What the hell? Why on D minus is there 3 volts? Here on plus there should be 3 volts. Here there should be nothing. Here nothing. Here nothing. So there's something wrong with this. Did I make a short? I don't see any shorts. Okay, that's D minus. Okay, there's one thing which is not soldered. Let's solder it. I'm sure this is not the culprit, but I don't like how it looks like. And here there's no short. Now I can't test anymore because I don't have any voltage. I should put a header here so I can test it this way. Do I want to do it? No, I don't. I'm too lazy. Let's solder this first. This one looks like completely unsoldered. Some tin. Okay, now this is soldered. I will solder some header. Where are my headers? Here. I'll burn my fingers. Okay. These are one of the sacrificial 10k. Yeah, I will still mark 100k. I think I'll still mark them 100k so I don't forget it. 100k. 100k. Up. Okay, that's minus. I shall mark it as such. Minus. Plus. Okay, now I can try it again. Plus. Minus. So if I measure here, 3 volts, it goes here to D plus, right? Here. Here, this is D plus on one side, D plus on the other side. Means that here, either here or here there's 3 volts, but not on D minus. No. Okay, so this is fine. Now here there should be nothing. Oh, there's 3 volts here. The cable is not connected on this side. Why is there 3 volts here? There's no here on this side the cable is not connected. Why? How come there are 3 volts here? Who gives you the 3 volts? Oh, is there a short here between these two? I can't move the cable anymore. Is this possible? Let's... Yeah, there might be have... Yeah, that I think there was just a short here. Yeah. So now it should work. So it's just a short problem. It's not my understanding of USB. Yes. Ooh, it's very dim. But it works. Green means there's USB 2 data. Now, do I want to do the USB 3 now or do I want to do it afterwards? USB 3 is a bit of a pain. I think I will do the sideband use first. But I will put the USB 3 LED. USB 3 is blue and sideband I think is yellow. Yeah. Blue, and for blue 470. I have 470 cables. 470. That's blue, and we don't care which side. So now it will be impossible to put the LED in. Oh, It is almost. No, it will stand out. So it will stand out. That's okay. Blue LED, the resistor with it. Up. I will not do USB 3 right now. I will first do the sideband use. This goes here. Sure, the LED doesn't look nice how it is right now. Up. Let's remove the connections while we solder. Yep, the LED looks crappy. LED position. Ugh. Okay, that's one side. That's the other. Ugh. The resistor, that's not better. Okay. The other side and the other side. Up. No, no, no. What did I do? There's only one side of the LED which is connected to the resistor. Else they're put in parallel, which makes no sense. Up. Okay. So sideband use. Sideband use SPU on the cable. This, I don't think it is in USB 2 cables. I think it is only in USB 3 cables. Let me check the specification. Well, USB-C, I mean full featured. Full, so yes, there is no sideband use in USB 2 cables, but these are two single-ended wires. There are two of them, yeah. Which you can use for audio accessory, alternate modes in general. So could be debug, audio accessory, and so on. So you cannot use them with normal cables. You need a full feature cable. This is, well, normal standard USB 2 cables. That's a standard USB 2 cable. These should not have the sideband use. So let's update the picture, because there is something which is complete, and this is the USB 2 part. This is this one, this one, this one, this one, and this one. So let's put the yellow LED for the sidebands. And for yellow, what kind of resistor did I use? 470 also? For blue and yellow? Oh, blue is 220, not 470. Well, it will be a very dim blue. I made a mistake. Yeah, blue is 220. Because blue has a high voltage, something like 3 volts, 4 volt voltage drop. So let's solder the LED. So it doesn't move anymore. Okay. And on sideband use, I also don't care how the resistor is connected. So let's do it like all the other resistors. This way. Okay. This looks like a mess, but it's a prototype. It's allowed to be this ugly. Reworking it will be a pain. It shouldn't be rework at all. So move the legs. This one is not the one which should be removed. And this leg. Okay. So sideband use, there are 2 wires, and yeah, we'll simply check the 2 wires. Actually, it's not like USB 2 this time, because they are the 2 wires, and it's not only one side. Sideband use, well, I need to use yellow again. How do I do it? I think I do it like, no, I didn't do any of the other wires. So, wow, every signal type has a different way to do it. Okay. I think what I do is I go through SB1. Yes, I go in SB1. It comes out of SB2. Yes, then it goes back into SB1 and it comes out SB2. Exactly. This is a weird, as sideband use is a bit weird. I'm not even, yeah, on full featured cable, there are the wires, but not on USB 2 cables, that's right. I only know about, for the usage of it, I only know about, how is it called? Audio accessory, but I didn't try the other one. Debug, I haven't tried the debug alternate mode. And I think DisplayPort is also an alternate mode, although I'm not sure how DisplayPort works because I think they use one of the USB lanes of the, well, USB lanes, USB 3 lanes. There are 4 USB 3 lanes, and I think you just use 2 pairs to send the signals. Is 2 pairs enough? Or do you need 3? Normally you need 3 pairs. If you do HDMI, HDMI needs 3 pairs red, green, blue, and the clock is hidden inside. So yeah, I don't know how DisplayPort works as alternate mode. So here we have we need SBU1, which is this one, and it should come out. We will test it because I'm not sure of that. Well, we don't know if it comes out of SBU. Well, it doesn't matter, because if we switch it, it becomes SBU2. So will it work? Oh, I think I've seen a mistake here. So how do I do? VCC COM2 SBU1. Normally it goes out to SBU2. But if it is flipped, it goes out to SBU1. Okay, so there's a mistake in my schematic. Oh, sorry, you didn't see the schematic. So yeah. And I need to put 2 LEDs there. Oh, how can I check it? So yeah, for example, here I put VCC in. I expect it to go out of SBU2. But if the cable is flipped on this side, so this is the normal, but if the cable is flipped, it goes out to SBU1, which is minus here. So this will not work. So actually I need 2 LEDs. I also need an LED on the other side. Or is there another way? No, because I don't know the polarity. And I want to check if both cables are present. So I need to have VCC and ground. So I will just put it this way. The LED will be reverse biased, but there will be no issue. No, there shouldn't be any issue. Let me think. If it's connected here, it will be the one or the other one. But if it goes here, is the voltage enough? No. The minimum voltage, I think the minimum LED voltage is red. It's 1.8 volt. And here there will not be 1.8 volt. So there will be only 1 LED. So I need to put 2 LEDs here. There, I found a mistake. And then it goes the SBU. And no matter what, yeah. So I need to put 2 LEDs. So second yellow LED. And this time I need to put up. Can it fit this way? No, it can't. I'll put it here. And this one I need to put the cathode on the other side. Like this. Okay. Luckily, I made a prototype. Let's check. Let's try it without. I'm sure it won't work. Let's try it without. Then we can still patch it. So SBU goes to SBU1. Actually, it doesn't matter if it's SBU1 or SBU2. We will just put it in SBU1, which is just below VBus. It is here, which is this one. Up. There will be a reverse bias LED, but it's not strongly reversed bias, so it will not break. It can hold these voltages. So this is one side. So it comes out of SBU2, which is this side. Yep. Let's thin it. Let's put it in the holder. Like SBU2 is it the one on the opposite? SBU, yeah. I like my adapters. The more I use them, the more I like them. This is SBU1, so it comes out SBU2. Actually, it doesn't really matter, but we will do it like the schematic does. And I will try on the cable, actually. Up. So this is SBU2. Then go through the positive of the LED, which is this side. that's the positive of the LED. Then, oh, it's not well soldered. Everything looks crappy soldering. Not soldering, but the wire management. Luckily, with this proto board, we have 3D wire stack-ups, infinite number of layers. So this is the plus, this is the minus, this is the minus, and the minus goes back to SBU1. Let's tin it. That's the LED here. SBU1. Okay. SBU1 is just on the opposites. It's right here. And before we connect it to this circuit, we will test it with the multimeter. That's this one, right? And then from SBU2, according to the cable, it comes in SBU1 and comes out of SBU2. I don't know why, but that's how the cable specifies. That's how the standard specifies it. Standard. I don't know if it's a standard. It's a specification, but it doesn't. I'm not sure it is part of any. So, and this goes to minus, which is on top here. But I don't. Is the USB a standard or is it just a specification? Is there an European authority which makes it a standard? I don't know. Not every specification needs to be a standard. At least it needs to be specified. Just making it a standard is just so it's compliant to EU any kind of regulation. For example, I know the difference because of mobile networks. Because I used to do a lot with mobile telephony, mobile networks, and there the 3GPP writes the specifications. So they really write how the networks, how the telecommunication networks are done. Well done. How they work. And then the ETSI, at least for Europe, takes the specifications from the 3GPP and makes standards out of it. Most of the time is copy-paste. Sometimes there are some changes. And most of the time it's political changes, but not always, or regulatory changes, for example, for emergency calls or for ciphering and things like that. Which algorithm you are required to implement, which one you're not allowed, which one is optional. These are country regulations more than specification. The specification specifies all of them. So let's actually test the SBU theory. Let's go back to continuity tests. I don't need alcohol anymore. You put here continuity tests. This one, this is a USB 2. This is a USB 2 cable, so there should be no SBU at all. So there should be no cable here, and there should be no cable here, and there is none. And this is why also they're thinner compared to here. This full featured cable a lot thicker because more wires. So let's test if this is correct. Does it have an SBU connection? So SBU1 should come out of one of those. Yeah, of this one, but not this one. And then this one should come out here. Yeah, so there are two wires. And actually, I implemented everything in my USB cable tester, the big one. So I should know about it. But it's 2 years. It's been 2 years, and in 2 years you can forget a lot of things. And this is right. I write everything down, so there's a huge documentation. about the cable tester in the code in a README, so I can find out fast again. Okay, so with my theory, now we can test this thing and it should work. So let's test it. Plus, minus. If I plug the USB 2 cable, yellow should not light up. It doesn't, which is good. Other way around, it doesn't. This is good. Now the full featured cable, which are a bit more expensive. Up. Currently nothing lights up. That's good. If I connect it this way, this lights up. But if I connect it the other way, it should not light up. Exactly. And this is where I need to put a reverse LED. So the reverse LED should be reversed this way and soldered in right there. So let's solder it and then try again, and then I have to fix the schematic. Don't want to desolder, I want to solder. Okay, this should work now. Plus, minus, there's no short. One side. The other side, so the one LED works. I could have at least, yeah, don't care. Centered the LED, but I didn't. And the other side works, yes. So this is correct now. So I need to put 2 LEDs for that. It's not the only one where I need to put 2 LEDs. Now let's do USB 3. USB 3, there should be 4 pairs in the wire. So the super speed, actually. It doesn't have to be USB 3, it can be USB 4, and it can be used in alternate modes for HDMI or things like that. So it doesn't have to be USB 3. But I will call it let's call it super speed. These are 4 differential pairs. There should be 4 differential pairs in the cable. In this one, there are no differential pairs. In this one, there are 4 differential pairs. This is again why it is thicker. More wires inside. And how I do it is plenty of blue wire. For USB, we will use blue. So let's update the schematic and let's check the schematic again how it is. So the schematic SPU, this needs to be fixed. Attention here. But this is done. SPU here is done. Here is done. Here it's done. This is done actually. This is done. Okay. How I test the 4 wires. VCC comes to TX1. TX1 goes out of RX1, then it is bridged to RX1 minus, which comes out of TX1 minus, TX minus 1. This is the first pair, then it goes to RX, RX goes to TX, which is then bridged to TX minus, which goes through the LEDs, and it does the same with the 2 other pairs. And actually the LED can be put anywhere in the circuit here. I just put it here this way. I think when I will do the routing, there will be a better place to put the LED. But here I put it between pairs, between pair 3 and 4. No, 2 and 3, between 2 and 3. But it doesn't matter. I'll change it during the routing. What makes it easier? What makes it easier? The LED is already there. Yeah, that's a blue LED. So let's thin the wire. We start with plus, like always. Don't have a lot of pluses anymore. Oh, I do have a longer bar, a longer rail, because I added the connector. Okay, plus. It goes to TX1. Where is TX1 plus? It's this one. I don't know. I don't know. That's a good question. Theoretically, you have all four pairs. Are there cables which don't have 4 pairs but only 2 pairs and tell that they have only 2 pairs? I don't know. I really don't know. And I wouldn't think so. I think if you pay for USB 3 full featured cable, you probably want all the pairs. So I would not expect, but poof, I really don't know. So it comes here, in here, then out of, so TX1, out of RX1 plus, which is right, which is this one, and then it goes here. So what we simply do is we short these two. We short these two. Sacrificial. Is this one of the sacrificial ones? No, it's not. Actually, yeah, I don't think I haven't seen any cable which doesn't have all 4 pairs. Cable which I've seen have the 4 pairs and not only 2 pairs. But I will see with people contacting me and telling me, oh, when I get cables and when I put inside. And what's good is with this USB cable tester, not the USB-C cable tester, but the full featured one with all the pins, this will be easily discovered what the problem is and which pair work. But for now, I don't need that. So RX, you see, TX goes here, goes to RX1. RX1 on this side is shorted to so the plus is shorted to the minus. Then it comes back TX1, which then should go back to, oh, it comes back to RX, no, it comes back to TX1 plus, TX1 minus, which is here, and this should go to TX2. It doesn't really matter what the orientation. I said RX1. The routing will, I'll change it with the routing. But for now, it goes to RX1 on this side plus. So let's do it this way. I don't want to think I can do 3D wiring. When I will do the routing, it will be different. And I think I will short it another way around. But for now, it's this way. So yeah, the prototype will not be the same as the PCB, but the concept is similar. So RX1 plus, it's this one. RX1 plus. Tack. So this goes to, so this is RX1 plus, this goes to TX1 plus, which is this one, and these two should be shorted. Well, we will short them. Don't want to short them with ground. Okay, shorted. So it goes back to Rx1 minus, which is here, and this one goes to the LED, right? Yes, it goes to the LED. At least on the schematic. Up. The plus is on the bottom of the blue, which is this one. This one here. No, damn it. Hope it's long enough. Just. Okay. Then it goes out of the LED to this cable, and it should go to TX2 plus. TX plus 2. Actually, they don't call it so. Previously on USB 2, you know the name D plus, D minus, because, well, it's a differential pair, and the one, it's a differential pair, and you have always a plus and minus in a differential pair, although they switch all the time. But on USB-C, I don't know if it's on USB 3 already, but on the USB-C specification, they don't use plus and minus anymore. They use P and N, positive and negative. And I don't know what they changed in the middle. I think probably because most software have no issues with the name plus and minus if you write code. It might be because of that, but I don't know why they switched. And even the USB 2 lines are called positive and negative. I don't know why they switch exactly. I'm not part at all of USB. So this is the minus. The minus goes to takes 2 plus, which is this one here. But you will still find a lot of, I think, even if in the Wikipedia it show you it is D plus and D minus on the picture, although in the specification it's D positive and negative. Matter, who cares? You just don't have to be confused and know about it, and then it's fine. Okay. So this is TX plus 2, the TX positive 2. It should come out RX positive 2, which is this one, and we will short it to the next one. Same. Tack. Then it goes out of here, and it should go to RX. And it's 10 it. So it comes out of here. And the RX is RX2 is on this side, so RX plus 2 is here on top. That's the one. Not enough. RX plus 2. Okay. Then it goes to the TX, which is here. We will short both of them again. Up. And it goes out of here, and this goes to minus. And then this is done. Then we can test if this works. Minus goes through this minus. There probably, yes, I think there are 100-watt cables which don't support USB 3. So the electronic marking is not mandatory on USB 2 cables. It's optional. So I think there are cables which are 100, yeah, probably sure, which are 100-watt but only USB 2 and not USB 3. So this is done. This should be actually working now. Let's try it out. Minus, plus, there is no short. No, even you see there is no short. Now let's try with the USB 2 cable. Nothing should appear. Well, nothing. These three, that's normal. And now with the super speed, or the full featured cable, it should work, but it doesn't. So I did something wrong. No blue. Yep. There is no blue. So either my soldering is wrong or... Ah no, there is. See? When I bend. Ah, okay. I think the soldering on my connectors is not good. Because when I bend it, it works. And it should work on the other side too. Yeah. Yeah, it's just... Yeah, somewhere, I don't know, is it this one? Or is it this one? On this one. If I bend it up, it works. So, and I don't see any fault. I don't know where the fault is, but it is on this solder connection. But I think, will I be able to fix it? I don't. Let's try it out. I think it's somewhere on the back here. Let's try some flux. Yep. Okay, resoldered the joints. Let's hope it works better. Let's try to resolder them also here. It does. It's this one. No, I don't think it comes from the through hole. I think it just comes from the SMD part. This one. Okay, let's try if it works. If my soldering fixed it. Without power, it won't. minus plus. Oh yes, it did. My soldering fixed it. So while I was testing, I probably was testing the wrong way. So I wasn't testing really strongly. But this is version 1. Version 2 is tested a bit better. Let's clean the solder flux. It looks, I don't need to, but looks ugly. Up this side and okay, flux removed, flux cleaned. So this works. That's good. Now comes the really hard parts. The CC connections and testing if there is a chip inside, and I'll explain you how it works. So this is done. This is done. That's done. That's done. That's done. Let's first do the easy part. I do use 2.2. The green was not bright, was it? I remember that the green was not really bright. I used 2.2. Wrong way around. 2.2 kilo ohms, but I should use 1 kilo ohm. Yeah, the green is not bright. Let's use 1 kilo ohm for green. No, I can't. This is where I can't. This is where I need to use 2.2 kilo ohms. Do I have some here? Or 2 kilo ohms? Didn't I put 2 kilo ohms? 1K? Didn't I get 2 kilo ohm resistance? Am I going? No, here, nice. Here. Well, let's try with 2 kilo ohm. That should also work. Ideally, it works with 2.2 kilo ohms, but let me explain you. So, in USB, you have what is called CC, the connection control. Yeah, I think it's connection control. You have a CC wire which goes through. Why is the USB here? You have it's also in here actually. You have a CC wire which goes inside, and it is connected on CC1 or CC2 on either side. The connection control is there to actually figure out which orientation it is flipped. And this is why on my boards, like this one, which have resistor, pull-up resistor, it is connected to the CC pin right there. And on the CC pin, depending on the resistor, it means I'm a host or I'm a device, and it tells you which orientation both sides of the connector are flipped. The problem is that you don't know if it's on CC1 or CC2. What you do is normally, so CC1 or CC2, because it is always flipped. There is one wire on the other side. So if it is connected, for example, if the wire is connected to CC1, on CC2, there is an other wire, but it is not mandatory. In our electronic mark cable, it is not inside, and on not electronically marked cable, there is no wire. On electronically marked cable, there is a wire, but it is only there to power the chips which are inside, which to identify the cable. So there is no communication between both ends. There are diodes which prevent any communication from one side going to the other and the other way around, or any power. It is really just a power from the inside, and this is on CC2. And to indicate that that CC2 is there, and then you should put some power in here so it can power the chips inside the electronically marked cable. In the cable, there is a pull-down resistor, which is called RA on both sides actually. And RA is around 1 kilo ohm. So how my USB-C cable tester checks if it is electronically marked or not is there is a transistor which is pulled up by default, which is, this is the PMOS, P-channel MOSFET, so the PMOS, which is pulled up to VCC. So by default it is switched off. So when it is switched off, it actually, did I do it right? Yeah. When it is switched off, this is not called power. This is called PD. Now EMARC. It's called EMARC. This LED. Still red, but it's not power. It's copy paste mistake. So this transistor controls this EMARC line, which powers the EMARC LED, which indicate if it is there. So it is by default pulled up. Now, if there is an RA resistor, it will pull it down, and it would pull it down to the MOSFET at a low threshold enough that this will activate the LED. So this is why the value of this resistor is important, because it will form a voltage divider with the CC2. You could also use op-amps actually to measure and measure the difference if it's connected or not, and compare to 2.2 volts. But I wanted to use transistor because I'm not that familiar. Yeah, the problem with op-amp, if you don't have rail to rail op-amp, you will only have, this is a 3 volts battery, so you will only have like 2 volt outputs, or one, even less, and that's not enough to power an LED. Well, the red is enough because it's 1.8 volt, but it's really not a lot. This is why I used transistors instead of op-amps, and rail op-amps are expensive. And the transistor, if RA is present, it will pull it down enough so the transistor switches on. And on the BSS 48, the voltage gate source is -2 volts, minus 1.7 volts. So it will pull it down at least minus 1.7 volts for it to work. And since we have 2.2K and 1K, it will pull it to 1/3, so to 1 volt. So it will pull it down by 2 volts. So this will work. And this is what we will try. So, and because you don't know on which, actually, it can be on both sides of the, it is on both sides of the connector, but you don't know if it's on CC1 or CC2. And this is why you see it 2 times. You see 2 transistors, because I don't know on which one it is. And I only use it on one side of the cable, not on the other side of the cable, because that's enough. If it's on one, if it's on one side, it's also on the other side, because you can plug the cable on both directions and you still must be able to communicate with the chip inside. And sometimes there is only one chip, but if they don't want to put a wire to power the chip on the other side, they simply put 2 chips, and you don't know which it is. You actually don't know which version it is. Actually, can you? Do they have a serial number? Maybe the chips have a serial number, and you can ask this one or this one for its serial number, and then figure out if there are 2 chips. I don't know, but it's just to identify. This is how this is the secret, and this is actually the most complicated part in this circuit, which needed a bit of testing and a bit of figure out. You could do it with a microcontroller, absolutely, which figures out if there is a pull down or not. And I wanted actually to use a 3-cent microcontroller, but they cost 30 cents now. So it's not worth it. 30 cents for just a checker. If I can do it with 2 MOSFETs, which cost 2 cents each, it's easier because I don't need to program it. I don't need to write firmware, and it works. But ask me 6 months ago or 1 year ago, I would not do it with an analog design. I would do it with a microcontroller before the shortage. Now it makes it a lot. It makes it simpler. It doesn't make it prone. So this is the hard part. So we will put a 2 kilo ohm, and we need 2 green LEDs. 1, 2. We need 2 because yeah. Why do we need 2 LEDs? Because we only test. Something fell. What did fall? I don't know. something. Probably just a resistor or something like that. Why do we need two? We need on the problem if we connect the 2cc to power this LED on this side. If we connect it directly to the 2cc, because this is where the power will come, so on this side it will light up, but on the other side there will be the pull down resistor. So it will pull down the power too much that if this side is also connected to the green LED will not go on again. And this is why we need two green LEDs for each of the CC lines. One for each CC line. So let's have the two, and we need one resistor for the two LEDs. Let's align it with the other. Yeah. Let's put it here, and let's put the resistor. And the two, I need one. Where did I put the resistors? I need two resistors, two resistors. I will put them here. And this is where the resistor is a bit different, because I cannot put the resistor right here in front of the LED. I can't put the resistor right here in front of the LED like I did with all other LEDs, as you've seen why I've soldered it, because the resistor needs to be on one side and the LED on the other side, because the resistor will form the voltage divider if there is an electronically marked cable, and on the other side, this is where the LED will go on. Actually, can I put the LEDs here? Let me think. Can I? Yes, I could. No, I can't. No, I can't. Because this needs to be after the resistor, and the resistor is inside here. So yeah, I can't. What is this? Are these? These are 2K values. So let's do first the CC line, and then, well, the CC line, and not the VCon line. The other one which is not going through is called VCon, voltage connector control. Well, it's connection controlled. There will be one LED which is right there, it will be here, and then the transistors. This will not be pleasant to solder. Actually, I could put the two resistors on top here, and I will. This will be a lot of wires. Yeah. So what? Actually I can directly connect, they go to plus, both of them. Yes. So I can directly connect them to the plus line. Oh, nice. So yeah, the placement here is quite good. So this goes to plus. Which I use green for CC, yeah. So, where's my holder? Green. Green. This goes to, well, let's see, we don't care which one is which one. This resistor goes to the CC, and CC is which one? I think. This one. Okay. I don't care if it's CC1 or CC. Yeah, let's have it somehow clean. This is CC. Up. 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 Okay, that's CC. CC1 or CC2, well, no matter. Doesn't matter. They're all the same circuit, which is duplicated. Yep. Up. It goes to the other CC, which is this one. And the CC wire is used for the power delivery communication. This is where the host and device can talk to the cable, but not only that, they can talk between each other. And this is most important if you have a device and charger, because the device can ask the charger, what are you capable of? Please give me 5 amps and 20 volts. And this is done on the CC wire connection control. And it doesn't have to be a fast communication. I think it's 400 kilobits or something like that. I don't remember exactly. But the communication is a bit weird because it's on 1.2 volts, 1.5 volts. So this is the CC. It comes out of either connection. So again, doesn't matter where I solder. And we go to the plus of the LED, which is on top. And then it goes directly to minus, right? Yeah. Yeah. It doesn't go back because there's no going back. There's only one CC wire. And how do I know that the anode is on top? Simply because again on the LED, the longer lead is the anode, so it's where you connect the plus. So this goes here. second green wire. And this CC wire is, I haven't seen any USB, although, no, USB 2, USB A to USB-C cable don't have it, but I think it is mandatory for, no, it's not. Actually, it's not. I think, so for all specified cables, the CC wire is present, but I'm sure one of the magnetic cables I want to test don't have it. So if they don't have it, you cannot ask for more power. You cannot ask for 20 volts and 3 ampere. You have 5 volts, and by default it's 3 ampere. Now it's not true. It depends on the resistor, which is set on the source side. This will tell how much current it is capable of. Oh, I didn't think about that. What if this resistor is plugged in the USB? Oh, yeah, this is too complicated then, and it's a crappy cable, so I won't have the case. What if, like the micro USB cable, which has battery charging included in the plug, which shouldn't be, it should be in the charger, they have the pull-up resistor in the wire? Then I'm screwed. But yeah, then my USB-C cable tester is broken, but I can still reissue a version. So now this should work. Let's test it out. Yeah, this I will have to see. I don't know of any cable doing that for now. Any cable cheating like that, but who knows. So, yep, the USB 2 cable should also work for that. Tack, there's at least a shield. Okay, it doesn't. And there's no short. There's no CC wire? No, that's not possible that there's no CC wire. Ah, I know. Yep. The LEDs need a path to ground, which they don't have right now. Let's use black. Oh, let's use green again. There's plenty of green actually. There's not a lot of black. Let's use black. Tin it. To strip it even more. And you go to ground. Right there. Up. Now it should work. Minus, plus. There's no short. I limited to 50 milliamps, but this will not draw more than 10 milliamps. And it's good because it's battery powered. Yes, it works. And if I flip it, it should be the other LED. Yeah. And this works. Now comes the most complicated, well, the most complicated. It's just a resistor. And actually test it with the full feature cable. It's just a resistor, it's just a transistor. But I'm always afraid of transistors. I've been burned by the unmatching pinouts. Yes, works. Wow, this is dim too. Surprisingly, the blue one is not the blue one I wanted. I thought it was dimmer. You never know. But this works. Okay, the CC line is detected. Now we need to solder. Oh, don't be too much of a brute here. We need to solder the transistors. There are two transistors. Up. Where's my here's my transistor box. PMOS, and obviously I didn't mark. I didn't mark the transistors. What is what is gate source drain? So gate source drain, yeah, it's this way. 1, 2, 3 gate source drain. Okay, two transistors. Let's solder them and then we will connect them. But let's first solder them. I want to solder them somewhere where there's space and where the LED will not be. The LED will be here. So I could solder them here or on the bottom. Let's solder them on the bottom. Up. See how tiny the transistors are? In theory, I could think the optimal way to place them, to rotate them, but the orientation of the thing, do I want to? No. That's the gate, that's the source. No, I will just connect how I think. Okay. One and the other one. And this will be red. I chose the red LED because the CC line is for power delivery. So since it's power, it's red. It will be a red LED. Could be any other color. The only one which is mandatory to be green or to be this color, the green color, is the CCY itself, because because I need an LED which is the brightest. Well, I need an LED. I need a huge resistor value, a pull-up. The higher the better. And the brightest LEDs are green LEDs somehow. Or at least that's the experience I have. Because probably we are more sensible to green, and green is more efficient. I don't really know exactly, but yeah, the brightest. Although here it's not the case, but I think the brightest LEDs are the green LEDs. We can try it out. Actually, here I have an LED tester. Yeah, it still works. And let's try all the LEDs and see which one is the brightest. You see, I cannot try all the LEDs. But let's compare always two LEDs. So this is plus, this is minus. This is 2 milliamp. Let's try red and green. Red is more bright. Red is bright. Oh, damn it. So it really depends on the LED. I have to test with SMD LEDs. So with 2 milliamp, red is brighter. Let's test with white. White is shinier, but this is because this is a clear one. But it doesn't look that good. Don't want it to be white. And let's try with yellow. Same. No, red is a tiny bit brighter. So green is probably not the brightest. I will have to use with SMD LEDs. I will try with SMD LEDs. And blue. Let's test. Blue is also nice. Also visible. I don't think it would make so much difference. So yeah, the green is not the brightest. It probably depends on the LED and the mixture of the LED. This is weird. I really thought, because on my Micro B, this is the one with the highest value. Let's test. Let's have it. Up. Up. So, on this cable, the green LED has the highest value. It has 2.2K, while red, let me check the schematic again. Yeah. And it is bright. This is, green is really bright. And it has the highest value. Then red, then blue. So, on this, someone is delivering something. Hello? Who are you? Okay, just the construction worker which lost the keys. But I'm back. So yeah, we can actually see the values. So yeah, the blue one has 220 ohms, 2 to 1. The green one 202K, and the red one is 01B. This is 1K. So yeah, the green one is the brightest, at least for these LEDs. But we've seen that with these LEDs, it's not the case. So it really depends. Up. But this is how it's done. So my circuit. We have the two transistors. Now the gate is connected to the resistors, right? Gate is connected to the resistors. Yes, it is. So gate is pin 1. It's this one. Let's use green because we used green. And it's connected after the resistor because we want to make a voltage divider out of it. The gate is connected to this resistor, and this goes here. Up. Okay, that's the first one. Let's try the second one. Up. So it is connected to the gate. And because I don't need any protection resistor on the gate because I already have this voltage divider, which acts as a protection resistor. And it's not that important for battery. So then we have the source. The source is connected to, it's a PMOS. So the source is connected to VCC, I think. Yeah, to VCC. So it's red. This is VCC. And there I can use one cable for both because they're both connected directly to VCC. And why PMOS and not NMOS? NMOS are more efficient, but we want to switch on an LED when there is a voltage divider. Well, can I do it with an NMOS? Let me think. No, because RA, the resistor in the cable, is connected to ground in the cable. So we already have the low side, meaning that it will be pulled low when switched, when it is present. So if it's pulled low when it is present, you cannot use an NMOS because the NMOS, you want to switch it on when it goes high. This is why you use PMOS. So this goes to pin 2 on both sides. Did I cut it too short? Yes, I did. Damn it, it's too short. Oh, let's... do I want to cheat here? No. Maybe it will work. Dun, dun, dun. I need to put more solder so it works. Okay, huge blood of solder, but it's good enough. And so the two sources, two sources are on plus, and then the drain needs to go to the LED, and the LED, we said that it will be a red LED. Red LED, and with red, I wanted, what kind? 1K. What is this? This is 1K. Up. I have still 100Ks, which I like. So the red LED will go the resistor just next to it. And then this is connected to ground. Yes. Oh, could I wait? Let me think. Because there's ground here, I will cheat and I will just bend it over so it goes to ground. So I don't need to make a cable. This is ground, yes. I could have put the LED. Ah, who cares? It is soldered now. Who cares if it looks ugly? Okay. And this is connected to the drain. And my screens are going to sleep. So it means that a USB display port has issues. One, and yeah, I will cheat. Don't want to spend too much time on it. One, that's the gates, and this goes below. Here. So that is, oops. Okay. These two, and there's one last solder point which I need to make, which is from this one to here. Up. And it seems to be complete, and now we can test it. I hope I did plug the transistors correctly. So, plus, minus, no short. That's good. If I use this cable, the USB-C should, the CC wire should still light up. The CC wire still lights up. Also, if I turn it around, or if I turn this one around, yes, but this one doesn't light up. That's good, because this is not electronically marked. This one is though, and yes, it works. So it's normal that it works if I plug just on one of them. That is expected, and it only works if I plug on this side. On this side it doesn't, because transistors are not on this side. But this should work, and the green LED should still go on for the CC wire. And it does. It works. My prototype... Oh, hope I didn't break anything. No. My prototype works. This is the USB-C cable checker prototype. And yeah, I have one mistake, one typo, and one mistake. And the proof of concept is done. I still need to label everything. I will label everything. But yeah, it is complete. And with that, I can actually start drawing the PCB. Yeah, I will need to put some label. I will put some label. But for now it's done. And I need to have lunch. So, enjoy the rest of the day. And my screen don't work anymore. And with that, I can actually start drawing the PCB up. So see you. Yeah, I will need to put some label.